Hi, welcome to Module 5 for ME BIOM 531 Materials Engineering class. In this module, you'll be learning about functional materials, materials which have specific applications in different areas. Before I start talking about this module, I just want to make sure you all know that this module has a lot of extra reading documents which are uploaded on RAMCT. These are required reading documents, so please make sure you read them as you go over the module. And it's going to be and the material which is included in this extra reading documents is going to be reflected in your homework as well as your exam. This module is going to be for 4 weeks and is divided into 4 separate modules. Module 5.1 will be talking about biomaterials, materials which are used for biological applications. That's one of the major applications of materials in life science. Any material that you put inside the body has certain characteristics and has to meet certain requirements, and the goal of this module is going to be to understand what makes a material compatible in a biological system. So we'll be talking a lot about how these materials can be tuned or so that they can be more compatible once they're implanted, how we can decide what is the success rate of these implants once they're put inside. We'll also be talking a lot about composites which are used as biomaterials. We'll be looking into composites of natural materials and synthetic materials. Natural materials such as polymers, which are derived from natural sources such as plant sources or even something like shellfish, and how we can combine them with synthetic materials and make biomaterials which would be successful once they're implanted inside the body. This module has one homework which will be due in 1 week. Also, there's going to be 2 research articles rather than one that normally you had so far. There's going to be 2 research articles that you'll be reviewing and writing 1-page critique on each of those and submitting that also on RAMCT within 1 week. Module 5.2, you'll be learning about semiconductor materials. As you all know, semiconductor industry is a very big industry, and materials that are used for semiconductor industry are very unique. So we'll be talking about those classes of materials, even though they are metals and polymers, but they are very unique class of materials which are used, and we'll be learning about that and what makes these materials so special that they can be used for semiconductor applications. We'll also be talking a lot about how these materials are processed. We'll be talking a lot about what techniques are used, specifically techniques based on MEMS, microelectromechanical systems, how to make chips or how we can process these chips, or what techniques can be used so that we can make electrical connections at a micro scale. You can imagine, our USB drives are so small now, how we can save so much data in such a small device. That's because we are making these materials, or we are processing these materials in a certain way so that they can hold a lot more data. So we'll be sort of looking into all those things, and the goal is to understand how these materials can be used for these type of semiconducting applications. In this module, you will have 1 homework, again due in 1 week. You'll also have 2 research articles. You will write 1-page critique on both of those and also submit in 1 week on RAMCT. Module 5.3, you'll be learning about magnetic and optical materials. Magnetic and optical materials I combined them in this one module just because they have a lot more applications based on, or there's a lot more understanding concepts based on physics, and we are dealing with materials here, so I wanted to kind of focus that, so I combined both of them. Magnetic materials are very commonly used for a lot of electrical applications. Most of the time when you have electrical applications, you do have an electrical field which is generated, and the result of a magnetic field that was applied. So it's kind of coupled together, and we'll talk a lot about not only the magnetic part but also the electrical part of materials in this module. We'll also be talking about some examples in which these magnetic materials are used. For example, magnetic recording, how we record audio or video on these magnetic tapes, and what materials are used and why we can store memory on those kind of materials. We'll be talking about that. In case of optical materials, we'll be talking a lot about what are the optical properties of these materials, what these materials can be used for. One of the examples that I can give you is an LCD screen or even an optical drive in which we can store data on disks and things like that, and what materials are used and why these materials are able to actually store the data. And so the goal is to sort of understand how these materials are unique enough so that we can use them for these type of applications. Again, you'll have one homework due in 1 week. You'll have 2 research articles. You'll be required to write a 1-page critique on both of these research articles and submit on RAMCT, also within 1 week. Module 5.4 will be talking about nanomaterials and a little bit about nanotechnology in general. Again, nanomaterials are this new class of materials. These nanomaterials are not made from any specialized materials. We use same metals in ceramics and polymers, and we just make them at a nanoscale, and by making them at a nanoscale they have a whole different set of properties, and that's what we'll be talking about in this module. We'll be talking about how the properties of materials are changed when you actually change their size and make them nanoscale. And nanoscale is something that we cannot see with our eyes. We need to use specialized equipment such as electron microscope to see all these materials. We'll be talking a lot about carbon-based nanomaterials, which were the first class of nanomaterials that were ever discovered. We'll be specifically talking about carbon nanotubes, which has a wide variety of applications, anywhere, ranging anywhere from electrical applications to biomedical applications. And the goal is to understand what is it in these nanomaterials, even though chemically they are still the same as bulk materials. What is in these nanomaterials which makes them so much unique, and why they are able to perform so much better than the bulk materials which are used. We'll also be talking a lot about nanoparticles, which are either made from metals or polymers. We'll be talking about semiconductor quantum dots, which have a unique property of emitting lights at different wavelengths depending on their size. So for example, a quantum dot of certain size, when you shine UV light, may show up as red color, whereas a smaller size may show up as a blue color. And even though chemically it's exactly the same, it has this different optical properties. So this module kind of ties or sort of ties in everything that we have covered so far, starting from metals and polymers and ceramics and composites to some of the functional materials that we have looked into. You'll have one homework for this module, which will be due in 1 week, and also you will have 2 research articles that you will be reviewing, and you will be submitting 1-page critique also in 1 week. If you have any questions, feel free to email me or call me during office hours. Thank you.